Okay, so I'm the guy standing between you and your dinner, so I try to make it fast. Raise your hand if you speak Hebrew. Okay, it's 99% of the people, so I will speak in Hebrew because I prepared this lecture in English, but I prepare spontaneous jokes in Hebrew, so if I may. טוב, מעולה. עכשיו שעברנו לעברית, בניגוד לא. Okay, sure. So we won't have prepared jokes in Hebrew. Great. So I will be a little bit more detailed without the marketing, without the business-oriented like aspects of the problem. Just like, what is the problem? How can we solve it? Which more like heavily algorithms. So a short bio, or as I like to call it, why maybe you should hear me out. So first degree, second degree, third degree in mathematics, computer science. 8 years of experience. Simcha, I'm following you 12 years to accomplish your step. Was partner in 5 startups. 3 of them has been sold, which is good. And in the last year, I invested my time understanding computer vision problems in the agriculture. Few comments about that. PhD almost. I'm seeing that this is not up to date. And Tehranis are hiring. This is all the marketing I will do for today. I just promised. So in debates I'm teaching you in the first lesson, I know this is the first one because I didn't pay for the second one, that you need to tell the people that's coming to the lecture what you're gonna talk about, talking about that, and in the end said like a quick summary. So the agenda for today. We will quickly review the farmers' problems. As you already heard in the last 2 presentations, I have a lot of problems, so quick review. We will understand how to exploit the data we have from farming. We try to see how we can use computer vision more. It's like remote sensing, but is some kind of combination between remote sensing and like real imagery. Well, as far as I know, because I was in the office, but they told me to have some images from some fields. We will present few conclusions from our experience, and finally, I will show you like some kind of template on how to solve computer vision tasks in agriculture. Specific in agriculture, this is not true for every domain. So, short review. I will make it fast because the 2 kind gentlemen on my right did my job. So we declare on around 30% of crop waste. This is not data from some kind of source. This is inner Tehranis data. So it's more or less the same numbers that had been presented so far. So the first problem, as described already, is fields are big. They're really, really big. I won't repeat the numbers. The main problem with big fields is the inherent uncertainty you have in the system, which has been presented as well. Fields are local and chaotic. Each agronomist that we talk about, they will present you, I had the field and like 1 hectare was eaten by rats, different part of the field was which low ground and had too much water. Fields are, generally speaking, very local, very chaotic. You cannot understand from a local phenomena anything about all the field. And finally, and most important, A/B testing is expensive because if you try to develop a new page in your site, you just deploy for half of your users to 1 page, the second half of the users to the second page. In 1 hour, you have like understanding what the traffic does. In agriculture, it's taken more or less 100 years, around 1 million hectares, and some kind of huge amount of money that I don't really know, which is careless because we don't have 100 years anyway, or at least not for now. So a few statistics. Great, this was a few statistics. More interesting ones. fields are becoming more expensive. Not only we need to feed more people, which is really true, it becomes more expensive as water sources becoming less available, as other resources like the Dead Sea becoming less and less available, the price becoming higher, and the ability to for example, you can see a graph showing the price of water for fields, which is just increasing and increasing over time. And indeed, interesting fact is when you're looking about the population of United States population in 1840, you can see it's around 132 million people. Today is around 320 million people. It's increased by a factor of 2.3, around time 2.3. For. But the amount of food that we provide, especially in corn by 1 hectare, is increased by a factor of 5, which is great because we, on the opposite as what has been told you so far, we see actually that we are able to feed more people and doing it right. Just like side note is right for the US, which is the most advanced culture and country when you're speaking about agriculture. This is not really true for India, China, Israel, etc. So I will claim that plants and satellites are good. They have their problems. They have like clouds and weather and a lot of problems, but generally speaking, they're providing good results, and you should rely on them. I had a really interesting discussion about why drones are good, but I think you have been convinced that drones are good and should be used in agriculture. So I want to say something a little bit different that has been told you so far. Let's say we're taking a field from a satellite. It looks like that. 1 meter for a pixel sounds really amazing because we worked with 3 meters for pixel, and we thought that is amazing. Give me your operator later. So when trying to understand a farm or a field from a satellite, you cannot understand the cause or the problem. You can get some kind of status of some indexing, NDVDI or something else, water indexing, etc. Satellite does not provide you good quality, it just provides you status. With the status you can provide yourself some kind of understanding over time, but not really inner thoughts and decisions. If I get a little bit more specific, I can use a plane. Get an image looks more or less like that. Using a plane, I can understand problems. I can understand local phenomena in my field or in general speaking in farms, and understand, I don't know, if I have diseases, if I had some kind of different problems. Again, this is not providing you the cause or the problem itself, it's just a local understanding of the problem, that it happens. When you get a little bit deeper using drones, you get something like that. We are actually using 3 millimeters per pixel. Again, 1 millimeter. Give me your operator. Again, so 3 millimeters per pixel is good enough for us. In the right bounding box, you can see insect. You can see nutrient deficiencies, diseases, etc., etc. So when we're talking about computer vision in the field, we don't talk about traditional remote sensing, but we want to use drones, high-resolution pictures to really understand the problem and to classify it correctly. So let's review some kind of problems and solutions that we have done in the last year at the agriculture. So the first one and most interesting, in my opinion, is the emergence. You have a new field. You just seeded the field a few days ago, and you want to understand how much or how many from the plants that you have seeded actually get rooted and will be like fully stand plants later. If there are agronomists in the field, like in the audience, please ignore my comment about full standing. I know this is not true, but So second, very interesting is understanding the situation between plants and weeds. So I don't really care if a weed is sick. Actually, I care because it's great. So I want to classify between different kind of plants before I classify different kind of diseases, problems, etc. So you can see in the red, generally speaking, if it's red, it's bad. In the red box, you can see a weed. In the yellow boxes, you can see plants, and this classification is really meaningful for farmers to get good decisions. Finally, very interesting type of indexing is line fraction, saying when you have a little plant and you can actually count them from above, you want to count them, but at some point they just like the leaves become one on the other, they have grow too big and you cannot just separate it correctly, not only from above but on the ground. It's very hard to separate them. So in this point you want to understand how you take advantage of your field. This kind of indexing line fraction provides you a way to understand how you really get out from the ground that you're using. For you can see again the red boxes are places when we as farmers thought we should have plants but didn't get rooted. But again, so I have a lot of images, I have a lot of tags, and what I can do with this is just a lot of tags with a lot of images on a lot of fields. I need to understand my data to get a good decisions. So generally speaking, heat maps. A lot of heat maps. You want heat map for the fraction, the emergence, the weeds counting. You want a lot of images, getting you a lot of data just for only a single field. Why? Because you as a human does not care about 1000 images. And believe me, I saw them. Like 10 hours of your work time is only looking on the images. So for a user, you want to give him something valuable. So something valuable is a heat map. Again, fields are chaotic and local, so heat maps a good approximation of the situation, providing a very beautiful result for the end user. More than just data and analyzing, as it doesn't matter how advanced your AI, you need to understand the problem. And to be honest, we don't really understand the problem because agronomists is not really good at explaining the problem to us. So we need to take the data that we have, get the knowledge from the agronomists and other farmers, etc., the people that are actually working in the field, to get a really good, smart decisions. Without this kind of knowledge, we just provide a very interesting but useless data. So this is a very important point. I think this is the most important point for everybody working on algorithms in the field. Good operations means stupid algorithms. If your drone are stable and if it flies correctly, if it's equally distributed, sampling the field, etc., you can ignore as much parameters as you want from your problem and get them really high results without developing too smart algorithms. And believe me, developing a smart algorithm is very expensive, and making a good operation is just a decision and some kind of effort from the tech, not the tech guys. Okay, so raw data is useless, we talked about that. And finally, I will like to claim that satellite, plants, and drones images provide you the full picture. Why? Because satellites provide you a status. Most of the time, if the status is great, you don't really care about much of like they put in effort to understand local phenomena. If the status is bad, you want to understand local phenomena, use your plan, which is much more expensive. And if the local phenomena are not really, you cannot guess the reason, you should spend much more money to understand the reason using drones. So 3 levels of imagery provides you the full picture. Just one layer is good, but not good enough. So I promised a really tech talk. So let's consider one of the problems I have been presented. So the problem is given a drone, which is important image of the field, count how many plants from a specific class are in the image. So I'm kind of lying to you because there are 2 problems here. The first one is detection, which is the counting, and the second one is classification, which is the specific class. So let me show you some idea to how to solve the problem. So the first point is you need to do some binarization to your image. Very big images, we work with 4,000 pixels on 6,000 pixels, which is 24 million pixels per image. It's enormous amount of data for single image, and you want to make it as light as possible. So Boolean matrices make very big, like RGB images, very small. They have like more clever compression techniques. If you're interested, talk with me after the lecture. So you have a binarized image. Morphology is a good idea. It's removing small objects, noises you have from the indexing or from the binarization. You want to increase the size of blobs or meaningful objects that you have in the field to see them more clearly, to make the signal more meaningful, etc., etc. In general, this is a good idea in computer vision. This is a good hint for any detection and classification problem. Label your objects. Later on, you will use this label to get something more complex. For example, you use it for ransack algorithm. We want to find lines for a few reasons. Line fraction to classification and different kinds of other case studies. We need to find lines. It's very important to say we assume this is some kind of assumption that there are lines in the image. This is not always true. For example, if you take images from Ukraine, most of the time you have like random field of weeds and a little bit of plants, so you don't have lines. Just like knowledge about Ukraine. Yes.
Do you have a visual example of this? Otherwise, I don't understand.
Yeah, sure.
What's happening with the visualization?
Yeah, sure. I talked with the CEO. All the images will be in the presentation. So we have ransack, and finally we will classify the results. So we have two kinds of classification. The first one is the naive one. We have lines. We assume that on the line we see plants, and outside of the line we see weeds. So we have some kind of machine learning, not really machine learning, even a stochastic classification, providing us most of the problem, reducing the calculation cost over a lot of images, and only on places we are not really sure about our results we can use the deep learning instance. I'm like a side note, I'm not really a fan of deep learning, but in computer vision it's very important tool in your toolkit, so you should use it wisely. Some secrets. So we use the inspection v3, which provides really good results. Don't use inspection v4 yet, it doesn't stabilize enough. So yeah. Okay, so this not up to date as I thought, so maybe for version 4 is stabilized already, but last time I checked 3 months ago it wasn't stabilized yet. So a few images. So this is the input images we got. As you can see, it's a little bit hard to see the plants because we don't fly 2 meters above the ground, we fly around 10 meters above the ground, so it's a little bit more problematic to see them. But after binarization, you can see them more clearly. The binarization technique behind this image is some kind of weighted mixture between NDVI and green filtering and some kind of this kind of indexing. Quick morphology providing like deleting the small objects, making the more meaningful blobs a little bit bigger, and providing us a good ground to work with. So if I ask you as humans to like tag me lines over these images, so most of the time it looks really easy, but if I give you a little bit of noise or a little bit of width inside the image, you can do two kind of grids. You can do the right one or the one that is orthogonal to the right one, which is really tricky, and we solved it out, but it's not really interesting in details. So the moment of truth, this is GGT. Indian people spend all of their life to tag me images, and I really appreciate them because I did it for 2 images and just like not enough for today. I went home, get to sleep. It was crazy. And this is the algorithmic answer. The lines provided you by a ransack algorithm, and the tags themselves. The white ones are plans, and the black ones are wheat. In the GT, all the black ones is just an bug that I had. It has been fixed, yeah, since then. Just saying. The second answer, this is the GT. You can see the lines and you can see the classification. Some of you will claim that we have problems, for example, over. Yeah, sure. Here. So you can see that in the GT we have some tagging there. In the algorithmic answer we don't have. This is actually not an algorithmic problem. This is a problem which Indians, they want to eat, and this GT has been taken a little bit before dinner, so we have problems there. So good recommendation, don't give your taggers to tag before dinner or breakfast. They don't do a very good job at this time of day. This is really true. Again, we want to understand, let's try a different problem. We want to see the line fraction. So we get another image. We run the same logic in this step. And the set step, we don't only clear the problem and understand something about it. We just give, I think the example will make it easier. Everything else is the same. So this is the input image, this is the output image. So the set step. As you can see, if you do a binarization of this image, you will see something very close to the output image, but you will see like some kind of very strange geometry, strange blobs. So you want to approximate them with ellipsoids. Using ellipsoids, you can understand the major axes, provide you the right slope of the of the lines, averaging the lines provide you the right grid slope of the grid, which really good final results. I want to say this, without even any basic of machine learning, deep learning, this is pure computer vision. I find it very interesting that in 2019 we still have very interesting results with so much classic machine learning, without classic machine learning even, just classic algorithmics. We don't need all the time deep learning. Right, Simcha? The reference, if somebody didn't understand the reference, this is the link for the YouTube. You should see it. It's a bin Ben theory, and it's a must for every nerd in the room. So, few comments. Deep learning, especially in computer vision and CNNs, good idea, very expensive. They work very well. I don't recommend them in detection. Most of the people will disagree with me. This is fine. They will have their tools which disagree with me. I really recommend it for classification. It has 97, 98% accuracy, which is great. Somebody in the last presentation talked about transfer learning. Works really well, works amazing. We trained our models on ImageNet and then do transfer learning, which about 25,000 images, works amazing. The second, less counterintuitive point is the dedicated solutions per problem is much better than an end-to-end single solution. There are too many problems, as I presented you and the other gentleman presented you as well. Too many problems is too different to just like give single deep learning network to solve them all. So don't try to solve them all in a single deep learning. Context-based searching. Again, you have a lot of data, you have a lot of metadata, use it. You get images, but you don't get only images. You can get weather data, you can get geometric of the ground. For example, if you know that some point, like some images you get is much higher than the surrounding area, you can take it into consideration and provide very interesting results. So take more than just the image, use metadata. So context-based searching is a good idea in this field. Again, classic algorithms doing fine. Don't just go straight forward for the deep learning. It's a good idea. It's most of the time solve your problem, but what happens when you have thousands of enormous images? I tell you what, it costs a lot of money and your startup is failing. So don't do it. And this is like, if you want to leave this talk with some, like, the most important point is, don't ready for users. This is fine. Make your inner processes better. For example, if you don't really ready for emergence counting for as end-to-end solution for the user, give it to your taggers. Tag which the AI most of the image. Make the tagger spend, I don't know, 10%, 20% of the time finishing the tagging and provide the final results to the user. It decreases in cost, it decreases in SLA, and which is a great idea. I'm repeating myself. And this is the slide that nobody likes because it's very long and technical and etc. But it should be good. So you can make a photo. So first of all, this is indexed as 0 because most of the people here computer science, so I wasn't feeling comfortable starting with 1. Get a problem to solve and a good camera. It's really important to get a good camera. Believe me, I tried to solve things without a good camera. Not so much. So after you have a question, a good camera, you need to talk with the farmers and the agriculture guys in general. They provide you some kind of problem, and then you talk with them and you understand they're like, yeah, we have this kind of problem, and then you try to understand the source of the problem and understand the completely different problem, like really completely different. So talk with them, understand the problem, and do it as you understand, because if you provide them the better results and saying I solve your problem, they don't happy either. So after understanding the problem, you need to understand the solution. Agriculture is with us for decades, if not hundreds of years, if not thousands of years. How many years? Yeah, 15,000 years. It's a lot of time. So they have some kind of solutions. It can be very primitive, it can be very bad solutions, but they have solutions. So first of all, develop their solution. Show them that you're at least good as they are, and after that you're providing them the solution, you can show them, understand the problems with their solution, and using this extra knowledge, develop your own better solution. At this point, I do recommend using deep learning because you need to do the next step. It's like a leap of faith for the farmers. You say, okay, your solution is great. I provide you a really good experiment presenting that I'm capable to mimic this solution, but now I can do much better. This is my deep learning solution. See, it's do amazing things, which it does. But again, very expensive. So after you convince your farmers that you do this leap of faith, you should sit down, get some money, get some time, and develop this same solution as deep learning less as possible. Sometimes you won't accomplish this task, but try to do it. Finally, after you do this stuff, you collect more data, you can support more cases, and believe me, there are a lot of cases that you want to support in each kind of task. Finally, if the client is happy, you are happy, so deploy the solution and drink a beer. If the client is not happy, please repeat step 4. It's while loop. So it was very nice to talk with you. This is my contact details. I will be glad to hear from you. DNC Algorithms is an outsourced company. This is my marketing time. It's outsourced company. We are sitting in Ramat Gan and Moscow. Tel Aviv was too occupied for us. Providing algorithmic solutions, machine learning, deep learning, cloud computing, and mathematical modeling. So if you need some interesting solutions, we'll be glad to provide them. Thank you very much.